what probability is, as you can see here, that probability is denoted what sample spaces total number of outcomes that are coming. If we have categorized under the categorization of dice, coins. If I am tossing 1 coin, 2 coin or 3 coins, so what will be the sample space that is as mentioned? So as you can see, that deck of 50 cards consists of what? 26 red cards and 26 black cards. Hello friends, welcome to another knowledge building series for IGCSE mathematics. Today we are going to learn and deep dive into the theory or concepts of probability. In the last class we have studied some basics of probability, but without wasting any time, let's get started. But before we do, please do not forget to like, share and subscribe to our channel. Let's get started. So in last class we have studied that what is OR rule and AND rule. So if you have been given that find the probability of this or this, so you have to do what? Addition of the probability. Similarly, if you have been given that you have to do an AND, so let's suppose if you have been given that you have to find the probability, two coins are tossed, you have to find the probability of getting a head and a tail, then what you have to do, you have to find the individual probabilities and just do the multiplication of that. And similarly, for the same example, two coins are tossed together, you have to find the probability of getting a head or a tail, then both the probabilities will be found out separately and then that will be added. You can write these rules and then we'll proceed with the next part, students. Okay students, I hope you have noted the AND on the OR rule. Now let's move forward and understand the concept of relative and expected frequency. So let's suppose if you have been given a probability for any event, so let's suppose it is given as to be 0.3 and you are saying that the same experiment is repeated n number of times, then what will be the relative or the expected frequency will be given by the formula that is given as to be the probability of the event and the number of trials. So if I am saying that number of trials is n, denoted by n, and probability is denoted by a smaller p, then expected frequency will be equals to what? N into p. So you can note this formula for your relevance. So I have stated an example also for you. So let's suppose if the probability of a spinner landing on the number 2 is given as to be 0.3 and the same experiment is done how many times? It is done 500 times. Then expected frequency will be what? N multiplied by p, that is 500 multiplied by 0.3. So the answer is coming as to be 150. So what you get from this is that we can expect to see 150 times the 2's, means the spinner landing on 2, and if the experiment is done how many times? The n is given as to be, the number of trials is given as to be how many? 500. So you can note this formula and then we'll proceed. Okay students, now let's proceed with the question and understand what expected frequency means. So here you can see the question has been given. So there are number of colored counters in a bag. Okay. Now this table shows the probability of picking each color counter from the bag. So probability is given as you can see in the given table. So color has been given to you. As you can see there are 4 colors and the probability is already been stated over here. So the question states that Lucy performs an experiment where she takes a counter, okay, and notes its colors and replaces it. So basically the total number of outcomes will not change. As you can see that there is a replacement of that color. Okay, she repeats this experiment a number of times. Okay, this information you need to make note of it, that Lucy picks a yellow color counter 12 times. So this is what? This is number of favorable outcomes that is coming under the question. Now I have to estimate how many times Lucy picks out a red color. Now simply what you have to do in this given question, I have been asked about the red counter and I don't have what total number of outcomes or the trials. So I can find it with the help of this data that is given for the yellow color. So P, probability of getting a yellow color, will be equals to what? Favorable outcomes You can write it over here, students. So P of yellow will be equals to favorable outcomes or trials, sorry, favorable outcomes only, and total number of trials. So probability of getting a yellow counter is what? Which is given as to be 0.2. Similarly, favorable outcomes is coming as to be what? You can see that the probability number of favorable outcomes is coming as to be 12, it is already stated, and total number of trials or total outcomes. Okay, now you can move this to the left hand side and do the transposition part. So total outcomes will be how many? Total outcomes are coming as to be 12 over 0.2. So this is coming as to be 60. So now you have the total number of outcomes. Now what the question states, that estimate how many times Lucy picks out a red color. So we have to specifically take the red color into consideration. Then now the expected frequency formula will be what? Expected frequency is equals to total number of outcomes, that is coming as to be 60, multiplied by what? The probability of getting a red counter. So this will be 0.15. So you can evaluate this. 100, this is cancelling out, this is 3, and so expected frequency of getting a red color counter with the probability of 0.5, sorry 0.15 is coming as to be what? 9. Okay, I hope you got the concept of this. What you have to do, first you have to find the total number of outcomes. For applying the formula for EF, that is expected frequency is equals to N into P. N is number of trials, total number of trials, multiplied by the probability of that event happening. Okay, I hope you got the concept. You can note the question, student. Okay, students, what expected frequency is, that we know now. Now let's move to another concept of solving the probability questions with the help of a Venn diagram. So we will understand it with the help of an question only. So here you have been given a question. Here you can see here that a number is chosen at random. So here this is given as to be what? This is universal set total. Okay, and this is set A and this is set B persisting of numbers, and number 12 is outside A and B. Okay, now I have to write down the probability of A intersection B complement. So as we have studied in Venn diagrams, so A intersection B complement will be persisting of this area which is common under B naught, that is complement of B and A. So only number 4 is coming under this section. So my favorable outcomes, I am writing it as FO, is coming as to be only number as 4. So probability of A intersection B complement is coming as to be what? So favorable outcome is only number 1. We have to count the number. So this is basically what? The number that is chosen. So number of favorable outcomes is coming as to be 1 only, and total number are, you can count, this is 1, 2, 3 and 3, 6 and 7. So the probability of this A intersection B complement is coming as to be favorable outcome is 1 over total number of outcomes we have evaluated as 7. Okay, now you can pause the video and apply the Venn diagram formula that we have studied on this to find it easily. So let's get started. So I have to find what? Probability of A complement union B complement. So as you can see that A complement union B complement will be what? Can be written as, this can be written as A intersection B complement. So what does that mean? So you have to exclude the intersection part, that is this part, as you can see here. So number what? 5, here is 5 and number 1 will be excluded. So we have excluded this part, okay, and rest all parts or the numbers will be considered. So you can see, you can count 1 and total number is coming as to be what? 5. So probability of A intersection B complement or probability of A complement union B complement will be coming as to be favorable outcomes is coming as to be what? Say 5, and over the total number of outcomes is coming as to be 7. So you can write this formula also and find your probability bit easier in that manner. You can note this down, students. Okay, students, this was pertaining to two Venn diagram, means two sets. Now let's solve another question which pertains three sets. So here I have been given a question. So 80 students in a year 4 are asked about whether they like what? Sharks, crocodiles or hippos. So I can name it as S stands for sharks. Similarly for crocodiles it's represented as C, and for hippos the third set will be represented as H. Okay, now the first line has been done. Now let's read the data and assimilate according to the Venn diagram that is being given to us. So all 80 students at least like one of the animals. Okay, so there will be no 0 in the intersection part or the common part. 15 students like all three animals. So this will be what? As you can recall, so this is the intersection part of all three sets. So I can write the number as 15 over here, because this part, as you know, that it represents the total of what? A intersection B intersection C. Okay, now 14 students like shark and crocodiles but do not like hippo. So this is a specific information that is given to us. So this will be represented as it is. So the number that is coinciding, that is sharks and crocodiles. So this will be represented 14. This section S intersection C will be represented as for the number 14. Okay, now 23 students like crocodiles and hippos. So what does this information mean? That this is a specific information, but this information is not specific. So it is not saying that it doesn't like, or the student doesn't like what? Sharks. So 23 students like crocodiles and hippos. So crocodiles and hippos, you can see here, if the number that is being written here will be subtracted from the total number of students, as this is the common part, and already we have included number 15 into the consideration that like all three of the animals. Okay, so this will be considered as what? So answer will be 23 minus 15. So this will be coming as to be 8. So this intersection part of crocodile and hippos will persist of the number as 8. Okay, now 21 students like sharks and hippos. This is similar to the previous statement that was given. So similarly, sharks and what? Hippos we are talking about. This set and this set we are talking about. So 15 is already there. So this will be considered as what? 21 minus 15. So my answer is coming as to be 6. So this part will pertain the number as 6. Okay, now you can see here that 44 students like crocodiles. So as you can see that this whole set of crocodile will be equal to what? 44. So how to find that this area? So how to find that? So the students that like only crocodile, so this will be evaluated as how much? So this will be total number 44, and the numbers that will be excluded after addition. So 14 will be excluded, 15 and 8 will also be excluded. So I have to find the number of students that like crocodiles only. So this will be what? 44 minus 29, and this is 37. So answer is coming as to be 7. So this number will be stands at 7, because the number of students that like only crocodile is coming as to be 7. Now moving on to the next statement. 12 students only like sharks. So this area is already been given with a number to me. So this is coming as to be 12. Now I have to find this area, as the students who like only hippos. So what you will do, so simply you can write as the universal set number minus the number that are coming in the individual part. So this will be 12 plus 14 plus 7 plus 6 plus 15 plus 8. Okay, so universal set number, as we have already seen, that it is coming as to be 80. So this is 80 minus, this will be evaluated as what, 12 plus 26, 26 and 7, this will be 33, 39, 39, and this will be 47. 47 plus 15 is coming as to be what, 62. So your answer for this part is coming as to be 18. Okay, now the Venn diagram has been completed. You have to pick every information specifically, and you have to keep in mind that these type of statements can be useful in interpreting the Venn diagrams very easily. Now the A part has been done. Now the B part, a student is selected at random. So what is the probability that this student only like hippos? So as you can see that we have found the value as coming as to be 18. So P of event, that is liking of hippos, will be what, favorable outcomes. Favorable outcome will be what, 18, and total number of outcomes, as we know, that is pertaining to the universal set number. So this is 80. So you can simplify it and write the answer as 9 over 40. Hope that was essential for you to formulate the answer for the information that is being derived from the Venn diagram. So why do we use Venn diagram? Because the information collected is bit easier to formulate and understand, and we can directly find the probability just by seeing the Venn diagram. Now the next part is, what is the probability that the student likes crocodiles and only one other type of animal? So as you can see that we are talking about the crocodile part, means the students who like crocodile. So this will be evaluated as C. So crocodile part is calculated or taken into consideration, and only one other type of animal. So as you can see that only one other type of animal, that is crocodile, coinciding with me, the crocodile set is overlapping with is 14 and 8. Okay, so here I have to exclude this 15 and this 6 because it is not falling under the set of C that pertains to number of students liking the crocodiles. Okay, now this will be evaluated as what, P of E will be 14 plus 8, that is favorable outcome, over 80, that is total number of outcome. The answer is coming as to be 22 over 80. The final answer after deduction or taking an HCF into consideration is coming as to be 11 over 40. So that was very simple, and once you make the Venn diagrams, your answer pop up like that. Okay, so you can note this. This is very essential concept, and then we'll proceed. Okay students, now we have done the Venn diagrams probability. Now let's understand some concepts that are complex in nature and there is a condition applied to it. So for that, this is basically called as the conditional probability. So the first process in this is tree diagrams. So what does tree diagrams mean? So as the name suggests, we draw the branches as per the probability given for the question, and then we solve it by the and or the or rule. Okay, now so the probability of tree diagrams is the way of organizing the information when two or more probabilities are given to you. Let's suppose if I do a probability of tossing a coin. Now after that I do another set of probability. After this experiment, same trial is being done. So how to formulate the answer? Then we can use the tree diagrams for that. Okay, now some important points that you need to understand, that to use the tree diagram we have to see that the branches of the tree. So basically if I are talking about the probability of getting a head or a tail, if one coin is tossed, then the probability will be added to as equivalent to 1. You need to make note of it because this will be helpful in solving the questions when we are doing as such. Now similarly you can use the fractions or decimals as per your wish. Okay, now here you can see that we have made a note of it, that the probability of tree diagram that shows the outcomes of the first event and the ends of the branches, we have to write the probability along with the branches that we are taking into consideration for the tree diagram. So summarizing it, so tree diagrams are basically used for two or more events, and it is exclusively that they are independent or dependent events, so that we have to formulate your answer according to that. You can note this and then we'll understand with the help of an example. Okay. Okay, now let's break down this tree into the branches and solve some questions for our understanding. Okay, so in conditional probability, there are two types of events as bifurcated. One is if two independent events are happening and two dependent events are happening. So first we'll solve for independent events. In independent events, the probability of second event is independent of the first event. So there is no reliability, or basically there is no dependency of the second event happening on the first event and vice versa for first event on the second event. Okay, now we'll understand with the help of an example. So Mary has to catch two buses to work. The probability the first bus will be late is 0.1. Okay, this is written here, and the probability of the second bus will be late is 0.3. Here you can see this is second bus and this is the first bus. Okay, complete the tree diagram that you can do. Okay, and now I have to work out the probability that at least one bus will be late. So in at least, what you do, you take the probability of 1 and 2. So you have to start from the number as 1. Now here you can see that I have to complete this tree diagram. So this is the probability of an event that we are talking about. So this is given as to be 0.1, that Mary will be late. Now here you can see that this is the first branch of the tree. So this will both means 0.1 and this probability will add up and give me the answer as 1. Okay, now simply what you can do to find this value, you can subtract it from 1. So this will be 1 minus 0.1, that is this probability. So your answer is coming as to be 0.9. So Mary will not be late. The first probability for first bus is coming as to be 0.9. Now similarly, we are talking about the second bus. As you can see, you can directly apply this 1 minus P of event will be evaluated and giving you the second value of the branch. So here you can see that these both are independent events. So this is given as to be 0.3. So this will be what? 1 minus 0.3, that is 0.7. Similarly, these both are independent events. So this will also be equal to that. Okay. So I hope you are getting the concept. You just have to see that both the branches add up and give the value as 1. And similarly, to check your answer, in case we are moving further, then all the probabilities of these values will also add up and give me the answer as 1. So branches will add up and probability, the final probability will be equivalent to 1. Okay. Now the tree diagram is complete. So I have to work out the probability that at least one bus will be late. Now how to play it smartly, that you have to see here that it is asking at least one bus will be late. So if both the buses are what? Not late, so that probability will be excluded. So probability of at least one bus being late will be equals to what? 1 minus probability of buses not late. So we are talking about both the branches of this, that is not late. Okay. So what to do in these type of questions? You just have to apply the AND rule. Okay. Now this will be what? 0.9 multiplied by 0.7. So your answer for not late, I am representing it as not late as NL. So this will be coming as to be what? 0.9 into 0.7, that is 0.63. Now you can put the value in this and formulate your answer. So your answer for this will be 1 minus probability of happening of an event, that is for being not late, is coming as to be 0.63. So your answer will be what? This will be coming as to be 0.37. Okay, so in these type of questions you just have to apply the AND rule and multiply the probability to get the final answer for this. If you multiplying that, not late will be giving you the probability of both the events happening together. So this similarly late and late will be written as here and followed by consequent not late, and similarly this not late and late. So these both branches will be similar, not late, and this will be what? Late and not late. Okay, so I hope you are getting the concept and grasping it further. Now let's talk about two dependent events. That happening of first event also affects the happening of the second event. Now in a bag there are 7 counters. There are 2 black counters and remaining counters are white. So here you can see that total, it has been given here in the tree diagram, that P of E is given as to be what? 2 over 7, and that is signifying the probability of getting a black counter. Now total is what? 7. Okay, and rest are white. Now similarly I can find other values for the branch. Okay, now a counter is removed and the color noted. Okay, now you have to mark this. The counter is not replaced. If I am taking out one ball and I am not replacing it with that ball, so that ball or a counter that you can say here, so the object is not getting replaced, so that will be subtracted from the total number that we are taking into consideration. If I have 7 counters, I have taken out one and not replaced, then total number of favorable outcomes or total number of outcomes for the favorable outcome will be deducted and the answer will be formulated as per the new value. So let's suppose if we are talking about this statement, so earlier I had 7 and I have not replaced 1. So in this case, the probability of total outcomes that the numerator part stands will be denoted with the number as 6. Okay. Now a second counter is removed and color is noted. Now I have to complete the tree diagram and similarly work out the probability that there will be one counter of each color picked. So we are talking about what? We'll understand this. First we'll complete the tree diagram. So this is what? This is 2 over 7. So this will be 1 minus 2 over 7. So this is evaluated as 5 over 7. Okay. So your answer is coming as to be 5 over 7. Now we have got the probability of first draw. So the black probability of getting a black counter is 2 over 7 and getting the probability of white counter is 5 over 7. Now let's move to the second branch. So as you can see here that if I pick a black counter, so this will be what? So you can say that I have 2 black counters. So if I have picked one and not replaced, so number of black counters will be what? This will be 2 minus 1 and total number of outcomes are there will be counted as 6. So the probability for this tree, this branch of the tree will be evaluated as 1 over 6. Okay, now moving forward. So as you can see that the probability of getting black and white counter will be what? Will be subtracted from the 1 So this is coming as to be what? 5/6. Okay, I hope you are getting that. We have taken one counter and not replaced it. So the total is getting affected by the number of counters that we have taken out. Similarly, if in this I had what? White counter, so probability of black counter. So favorable outcome after picking white counter. So number of counters for black will be same. So I can write the probability as 2/6. Similarly, if I am going to talk about white and white, so number of favorable outcomes for white counters has been reduced by 1. So favorable outcomes are coming as to be 4/6. Okay. Now you can write the probabilities all together. So this will be what? This is signifying as black and black in both the draws. This is denoting as black and white. This is white and black. Similarly, the last one will denote as white and white. Now, I'll move to the question as my tree diagram has been completed. So, I have to work out the probability that there will be one counter of each color. So, I will exclude this part and I'll cross it and this part. So, I have to find the probability of getting a black and white or white and black together. So what I'll do, I'll apply the OR rule. Okay. So probability of event will be what? This you can evaluate. So probability of black and white will be, as you can see, you can just multiply these both and formulate your answer. Similarly, for the second case, I'll multiply this white probability and getting of a black counter, and I'll multiply these both and add the final probability for this. So I can write it as what? 2/7. As you can see, 2/7 multiplied by 5/6 plus I am talking about what? I am talking about white and black. So this will be 5/7 multiplied by this 2/6. Okay, so you can formulate your answer. This will be what? 10/42. Similarly, this will also be 10/42. Now your final answer is coming as to be what? So this is coming as to be 20/42 on solving by taking the LCM. So finalizing your answer by deducting with the common HCF, your answer will be 10/21. Okay. So I hope you get the concept that if first event and second event are independent, then how to solve the tree diagram. Similarly, if one event is dependent on the other and the vice versa is also true, that the second event is dependent on the first event, then the probability do change, and then how you have to depict and draw the tree diagram, and finally apply the what end and or rule for formulating your answer. Hope you have got the concept. You can note both the cases along with the solution for your future understanding. Okay. Okay students, I hope you got the concept for tree diagrams. Now let's do another question to understand the concept to the core. So this question states that Susie either travels by bus or walks to the shops. Okay, the probability that she catches a bus is given as to be what? 0.2. Okay, you have to make a note of it. The probability that she catches a bus from the shops is 0.9. So the first part, first you have to evaluate and complete the tree diagram. Okay, so first you can complete your tree diagram. This will be evaluated as what? As you can see, this is the first branch and this will add up to 1. So you can directly write your answer as 0.8. So I am writing the solution also. 1 minus this branch will be giving you the answer for this side. Now you can write the probability of an event also if you wish to. Now similarly, if I'll talk about this So how to find this value, and you can see that the question is itself answering that part. So you can read this line: the probability that she catches a bus from the shops is given as to be 0.9. So this is an independent event, so she catches the bus from the shop is given as to be 0.9. Similarly, this part will be 1 minus 0.9, this is 0.1, and these events are independent, so the probability will remain intact as above. So this can be written as 0.9 and 0.1. Now I have to work out the probability that Susie walks at least one way. So this is showing that both the sides are given as to be for the bus. This shows bus and walk. This is walk and bus, and this shows that it is walk and walk. Now what you have to find, that Susie walks at least one way. Now at least is coming, then you have to exclude what? You have to exclude both the part that persist of the bus value. As you can see that there is one walk part in this, and this will also be considered because we are talking about at least one walk side. So this will be evaluated as how? So you can play it smartly and solve your answer, that you can subtract the bus part, that is this probability, to find the probability of rest 3 altogether. Or you can do what? You can find the probabilities of these 3 and add up as per the OR rule and find your answer. So probability of this event will be equals to 1 minus probability of bus and bus. Now how to find the probability of bus and bus? So this will be formulated as what? This will be formulated as per the AND rule. So you have to find the value as per the AND rule. So this will be coming as what? 1 minus 0.2 into 0.9. So this will be 0.18. Now the probability of Susie walks at least one way, this will be giving you the answer, and the answer is 0.82. Okay, I hope you got the concept now. You can note for your understanding in future, students. Okay students, so we have come to the end of this video. We have thoroughly studied tree diagrams, sets. Okay students, so we have come to the end of this video. We have thoroughly studied the probability, the basic concepts, how to make the sample space, how to use the Venn diagram, and finally we have solved the conditional probability with the help of tree diagrams. So you can understand the concepts better, you can scroll down through our videos and practice more for these concepts. Thank you and stay tuned. Let's walk on the path of knowledge together by liking, sharing and subscribing to our channel.